Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Hello future engineers, here is another video in Engineers in Progress, hoping that the series of problems here on uniform motion can help improve your thinking skills, especially formulating equations and understanding phrases in algebra. If you want to anticipate the solution, then you can by pausing the video and answering these problems here by your own. So the concepts are already discussed and presented in the preceding videos in Engineers in Progress. So problem 44, two students are 350 meters apart and begin walking toward one another at constant rates. One travels at 1.6 meters per second and the other at 1.9 meters per second. How long will they walk until they meet? How far has each of them gone? So for the solution, because they are traveling toward each other from the ends of the 350-meter distance, then this distance is equal to the distance traveled by one student and distance traveled by the other student. So d equals d sub 1 plus d sub 2, and distance is average speed times time, or rate times time. So d, which is 350, is equated to 1.6, the speed of one student, 1.6 times t. Travel time is t, and the other one is also t. So plus 1.9 times t. 350 is equal to 3.5 t. So 350 divided by 3.5, the time is 100 seconds. Therefore, the distance traveled by the first student is 1.6 times 100, 160 meters, and the distance traveled by the second is 1.9 times 100, and it is equal to 190 meters. So that's a simple problem. Problem 45. An airplane flew 950 miles in 2.5 hours against a headwind blowing 30 miles per hour. How fast could the plane fly in still air? So time is equal to distance, which is equal to 950 miles divided by effective rate or effective speed. The effective speed is speed in still air of the plane, which is the unknown here, minus the uh, speed of the wind, because this is a headwind, so it is to be subtracted from the speed of the plane in still air, so minus 30. So time is distance over effective rate or effective speed, and distance time is 2.5 hours or 5 hours, and the distance 950 miles. Effective speed is v minus 30. So 5 hubs equals 950 over v minus 30. Then cross multiply 5v minus 150 equals 1900. So 5v equals 1 2050. 5v equals 2050 divided by v. So v is 41 410 miles per hour. So that's the speed of the plane in still air. Problem 46. Two airplanes fly towards each other from points 900 miles apart. At the rates per hour of 360 miles and 240 miles. So these are the rates of the two planes from the ends of the 900 meter mile distance. Then When will they meet? If they start at the same instant. So traveling at the same instant means that the travel times of the two airplanes are equal. So distance equals distance 1 plus distance 2. Distance traveled by one airplane plus distance traveled by the second airplane. So 900 equals 360 times time plus 240 times time. So 900 equals 360 plus 240 is 600. So 900 equals 600t. So the time that the two planes meet is equal to 1.5 hours. Then next problem 47. Uh, an airplane leaves an aircraft carrier and flies south at 350 miles per hour. The carrier flies south at 250 miles per hour. If the wireless communication range of the plane is 700 miles, when will it lose touch with the carrier? So take note that the aircraft carrier as well as the plane move in one direction, which is south. So let us say that direction is south. The plane moves ahead, and the distance traveled would be speed of that plane 350 times time, while the distance traveled by the aircraft carrier is 25 times time. They move at the same instant, then the difference of the distance traveled should be equated to 700 miles because that's the uh, communication range of the plane. So that is distance equals distance of the plane minus distance traveled by the aircraft carrier. So 700 equals 9 equals 350t minus 25t. So 700 equals 325t. So t equals 700 over 325, and that is 2 and 2 over 13 hours. So it is 2 with decimal, then in your calculator subtract 2, then that remaining value in decimal multiplied by 60, and it should be in this ratio 2 over 13, or you use your experience with dealing with fractions or mixed fractions. Problem 48. With a wind velocity of 30 miles per hour, it takes an airplane as long to travel 840 miles with the wind as 660 miles against it. How fast can the airplane travel in still air? So again, it involves equal time. So the analysis here is time with the wind is equal to time against the wind. And since we have the wind which is blowing against and with the plane, then time with the wind is distance over effective speed with the wind, then it is equated to distance against the wind and the effective speed against the wind, effective speed of the plane. Then the distance with the wind is 840, and the effective speed with the wind is v, speed of the plane in still air, plus 30, while the distance at the same time is 660 against the wind, and the effective speed is v minus 30. 840 divided by 660 is equal to this. We reduce this by dividing everything by 60. So 840 over 60 is 14, while 660 over 60 is of course 11. So 14 over v plus 30 equals 11 over v minus 30. Then we cross multiply. We have 14v minus 14 times 30 is 420 equals 11v plus 330. Simplifying, 14v minus 11v is 3v, and 330 plus 420 is 750. So dividing everything by 3, so v is 250 miles per hour. So that's the answer, the speed of the plane in still air. Then lastly, Problem 49. Two men start at 8 a.m. from the same place in opposite directions at speeds of 45 miles and 60 miles per hour, respectively. When will they be 240 miles apart? So it is the same as in the preceding problems here, like this one. So distance equals distance 1 plus distance 2. So 240 equals speed of one is 45 miles per hour, so 45t, then plus distance traveled by the second, 60 times t. So 240 equals 45t plus 60t. 240 equals 105t. Solving for t, 240 over 105, and that is 16 over 7 hours, or 2 and 2 over 7 hours. So 14 over 7 is 2. Then there is an excess of 2, so that's 2 and 2 over 7 hours. Then expressing the 2 over 7 hours in minutes, so 2 over 7 times 60, that's 17 and 1 over 7 minutes. So add this to 8 a.m. So 8 plus 2 is 10 a.m. So 10, 17, and 1 over 7. The time that they will be 240 miles apart. So that's it for this video. It's lengthy now, so I'm going to stop.